In this video, I'm going to show you how you can configure NAT reflection on PfSense Firewall. And NAT reflection is also called as HairPin NAT in generic firewall technology. And on my screen is the simple network topology. We have the external user network and the internal user network. The internal user network is in the same network as the web server, which is 192.168.0.190. And the external users are accessing the web server using the virtual IP, which is 14.140.40.192 from the outside internet. And the WAN interface is 14.140.40.109. LAN interface is 192.168.0.109. So usually what happens is the internal users, since they are in the same network, 192.168.0.0/24, when they try to access the server 192.168.0.190, they basically go directly to the server and then access the resource. But in some case, the administrator, because of some security reasons, would like the internal users as well as the external users to use the same path, which is via the outside virtual IP 14.140.40.192. And that is what we are going to configure here. So the internal user and the external users will, when they try to access the web server using the hostname, will get resolved to the virtual IP, which is the external IP 14.140.40.192. And then on the firewall, we will have the configuration to translate the address back to the internal server IP 192.168.0.190. And then the request will again go back to the LAN, and from the LAN, it'll go and reach the internal user, thereby achieving the hairpin NAT or NAT reflection. So let us try to configure the same. So the internal server hostname is centos.subnet.com. Now let's try to configure the PfSense firewall to achieve the NAT reflection. So this is the PfSense firewall running on 2.7.2 release. And as per the diagram, the external interface 14.140.40.109, internal interface 192.168.0.109, connecting to the web server 192.168.0.190, which is a Linux machine with the host name centos.sumit.com. The internal user is going to be 192.168.0.3, and the external user is 14.140.40.12 for the testing purpose. So first of all, click on System, go to Advanced, click on Firewall NAT, scroll down, come to the section where you see Network Address Translation. So here in my case, I have selected Pure NAT, and you can go through the description and select the option that suits you better. In my case, Pure NAT is the one that I have selected as per the diagram that we have and the scenario that we have. And coming down to the next option, enable NAT reflection for 1-to-1 NAT. If you have 1-to-1 NAT, then you can click on this option, but we will be configuring port forwarding in our scenario. So we do not need to check this particular option, which will automatically create the additional NAT rule. The third option is enable automatic outbound NAT for reflection. Well, we'll need this particular option, so make sure you check this option. That's it. After that, you can save the settings. Now click on Firewall, come to the virtual IP section, make sure you have the proxy entry there for the external IP, which is in our case 14.140.40.192. So I have created the entry for 14.140.40.192 on WAN interface so that the WAN interface can proxy for any ARP request for an IP 14.140.40.192. And at the same time, I have another entry on LAN interface for the same IP because we have the traffic coming onto firewall on LAN as well as on WAN interface, and we would like the firewall to proxy for any ARP request coming onto those interfaces. Next is the firewall NAT rule. Come to the port forwarding section, click on add and add the NAT rule. Select the interface as WAN, address family as IPv4, protocol any, and coming down to the next section, put the destination as the address, which is going to be 14.140.192, and the redirect target IP is going to be the actual IP. So this is the actual IP of the CentOS firewall, sorry, CentOS machine. So I've given the description here. And in the NAT reflection section, make sure you select Pure NAT enable and click on save. So now we have the NAT rule, which is the port forwarding rule on WAN interface, which says any protocol, any source, and any source port coming to the destination 14.140.40.192 will be translated to the actual IP 192.168.0.190, which is our internal web server or the Linux machine. So after this, we will have to create the firewall rule as well. So the traffic will be coming onto WAN interface for the outside network for the external users. So let us try to create the rule here. Seems like we already have a WAN rule from the source any, port any, towards the destination 192.168.0.190. Since the translation will happen before the policy lookup, so we'll have to mention the actual IP address of the server. In our case, 192.168.0.190. And let's try to test this particular settings for the traffic coming from the outside network from the external user. So this is the external user window-based machine, and I'm trying to reach out to centos.sumit.com from the IP 14.140.40.12, which is externally located, and the traffic will be coming on to WAN interface. And you can see here the domain is getting translated to 14.140.40.192, and the traffic is then generated from 14.140.40.12 to 14.140.40.192, and we are getting the reply as well. Let us try to take a capture on the PfSense firewall to understand the packet flow. As you can see, this confirms that the firewall is receiving the packet on the WAN interface, which is XN1 in our case, and the source is 14.140.40.12. Destination is 14.140.40.192. Now we'll try to capture the traffic on the LAN interface, which is XN0, to check out the natting. So you can see here that the source is getting natted to the LAN interface of the firewall 192.168.0.109, and the destination is getting translated to the actual IP 192.168.0.190. So when the PfSense firewall is sending the packet to the actual server, it is doing the source NAT as well as the destination NAT so that the reply packet comes back to the LAN interface. So now we have achieved the port forwarding from the external user until the actual web server. Now let's try to create the NAT rule for the internal users, which will be in the same network as the server. Click on firewall, go to NAT. So here you will have to create a new rule on the LAN interface, address family IPv4, protocol any. Destination is going to be, so the destination would be 14.140.40.192. This will get translated to the actual server IP. So this is the NAT rule, and scroll down, make sure you select the NAT Reflection, pure NAT. Click on save. Apply changes. So now we have two NAT rules, one on the LAN, one on the WAN, with NAT Reflection enabled. So now click on firewall, go to rule. On the LAN interface, we would need a rule which is already there here from protocol IPv4, source any, destination port any, destination port, source port any, destination port any, for the destination 192.168.0.190. Allow the traffic. Now let's try to test the same. So this is the actual actual machine which is in the same network. 192.168.0.3. Let's try to initiate some traffic. This will get translated to 14.140.40.192. And you can see here, it is getting translated to 14.140.40.192. And we are getting the reply as well. Let's try to capture some traffic to understand the natting. Let us take a capture on the WAN interface. So we were trying to take capture on the WAN interface, and on the WAN interface, you will not see the traffic because the internal user is initiating the traffic. So we'll have to take capture on the LAN interface on the PfSense firewall. And there is a continuous ping going on. So if you see here, you will see a request from 192.168.0.3 towards 14.140.40.192. And this is the Wireshark capture to confirm the same. The source is 192.168.0.3, destination is 14.140.40.192, and destination MAC, you can see here the MAC address of LAN interface because of the proxy ARP that we have enabled. So this particular request, when it reaches the PfSense firewall, is getting translated to 192.168.0.109, and the destination is getting translated to the actual server IP 192.168.0.190. And the reply you can see here, 192.168.0.190, which is the CentOS machine, sending the reply back to the LAN interface on the PfSense firewall. And that particular LAN interface is then sending the actual packet back to the source. So that confirms our NAT reflection or the HairPin NAT configuration is working fine on the PfSense firewall. I'll share the link for the network diagram in the description so that you can refer to the same and replicate it in your lab or in your production network. And the key pointer here is to have the firewall and NAT feature inside the network address translation, have the pure NAT or the NAT+Proxy enabled here as per the requirement. In my case, I was in the requirement of pure NAT, so I enabled the pure NAT, and make sure you enable this particular option when you're doing the port forwarding and when you want to achieve the NAT reflection. And if you're using 1:1 NAT, make sure you enable this particular feature. And to achieve the NAT reflection, we have the NAT rule. One is for the traffic coming from the outside network on the WAN interface, and the next rule is for the LAN interface for the traffic coming from the internal user onto the LAN interface. And we have the firewall rule on the WAN interface with the destination as 192.168.0.190, which is the actual server IP after translation, same as on the LAN interface as well. The IP address is after the translation. And in the advanced section, firewall NAT rule, if you see, they have mentioned where you should be using the pure NAT and where you should be using the NAT+Proxy. There are some limitations when you use NAT+Proxy, whereas in you cannot have range larger than 500 ports and will not be used more than 1,000 port total between all the port forwardings. So there are certain restrictions. You can only use TCP. Only TCP and UDP protocols are supported. And IPv6 is not supported. So make sure you go through the limitations of NAT+Proxy or PureNAT before you implement the same. That's all in this particular video. See you in the next video, and please do not forget to subscribe to the channel, hit the like button. See you in the next video.